recording now. So once we begin recording, we can actually start the class. And I'll be presenting this file here. Can everyone see the presentation?
Yes, sir.
Okay. I think everyone can see the presentation.
Yes, sir, it's visible.
Yes, sir. Yes, sir.
Okay.
Yes, sir. We can see, sir.
All right. All right.
Yes, sir. It is visible, sir.
Okay. Then everyone, let's take a short revision, and then let's do the exercises.
Sir, in my mobile network problem, so I'm joined in my brother number, sir.
Yes, very good. So if you have a network problem, always come with a different device. So you can also listen. There is no problem. Just once you complete the session, you can post your attendance in Google Classroom. This instruction is for everyone. So if my voice is clear, if my voice is not clear, it's probably because of a
Sir,
network
I have
issue.
posted my attendance, sir.
Okay then. If you posted your
Sir,
attendance,
I
very
have
good.
posted my attendance in my mobile, sir.
Okay. Okay. All right. So let me just continue. So about the voice and network connectivity. If my voice is not clear, it is probably because of a network issue. If my voice gets distorted at any time, just disconnect and rejoin using the same link. That will probably fix it. All right. And the next thing is, if you get a phone call or if you get interrupted in between the class, that's probably going to cause voice distortion again. So if you get a phone call, just rejoin the meeting. If you rejoin the meeting, it will probably fix it. Okay. So I think now that we got that out of the way, let's actually revise and then we'll start the new topic. I think in the last class we were discussing about algorithms. So let me just simply explain about algorithms, and Priya ma'am will continue. So algorithms is nothing more than a detailed step-by-step instructions that are written to solve any problem. So let's say you're trying to solve a problem. Like let's say you're trying to make tea or whatever the problem. If you have no idea how to solve it, we can probably decode the solution by writing down the steps to solve it. So writing down the detailed steps to solve a problem is what
Sir,
we
I
call as an
can't
algorithm.
understand this. You can say this one more time, sir. I can't understand this, sir.
Sir,
Okay.
you can increase your voice, sir.
Increase your voice, sir. Yes,
Okay.
sir. You
Okay.
can increase your voice, sir.
Am I audible now?
Yes, sir.
Yes,
Okay.
sir.
Okay. Okay. Just listen. Algorithm solving a problem. Okay. So if people encounter a problem in their life or in the computers, what people usually do is they just straight away go to solve the problem. Okay. Once they see a problem, okay, let's say there's a problem like 253 times 87. Okay, then let's say there's some sort of problem there. People, what they usually do is they usually dive into the problem, okay, without judging all the various ways in which you can solve the problem. Let's say you have this problem right here. If I give you this problem, all of you will just dive into solving the problem. But what people don't realize is there are multiple ways to solving this problem. Okay, so there are multiple ways in which you can solve the problem and you can arrive at the same solution. So there is a way of solving problems called as algorithms. In algorithms, what we do is we take a step back and then we look at the solution in detail. Let's say we want to find the solution for this mathematical problem right here. What we do is we try to take a step back and we look at the solution in detail. We take a look at all the different steps, all the different approaches we can take. We write down all the steps in detail. So writing down all the steps in detail is what we call as an algorithm. It can be applied to any sort of problem we have. It can be applied to making tea. It can be applied to driving a car. It can be applied to fixing a computer. It can be applied to making a program, writing a program. You can apply it to whatever you want. That is what we call as an algorithm. Algorithm is to simply lay out all the details in simple steps. Okay, here we have an algorithm to make hot water. So with this algorithm, anyone can actually make hot water just by reading these instructions. Okay, is that clear to everyone? We've already seen this in the last class. We're just revising. All right.
Sir, we see, sir.
All right then. So let's take a look at the next concept. Ma'am, do you want to take this one?
Sir, let me tell a simple example for stating this algorithm very briefly. Okay. Children, you can just listen. So, I am just stating you a very simple example. Okay. Everybody have Androids or the computer with you, right? So, if you find any issue in resolving the problem, right? If you find any issue in your computer, for example, what you do, if your computer is not putting on, okay, if your computer doesn't receive any power supply, what you do, you first check whether you have a power supply to your house, right? Once again, if it is there, what you do, you just look at the cable, wire connectivity that is fixed to the computer or the CPU, right? So once it is all checked, and then even though you didn't get the power supply to the computer, then it is probably some internal issue, right? So what you do, if you don't get the power supply to the computer to boot your system, first you check whether you have power supply at your home, followed by all the wires that is being connected properly to the computer, and then followed by your computer is putting on or off, right? So all these procedures we will look at to put on our computer, right? So this is a simple step that we follow in a very simple process, right? Okay, so that is what called as algorithm. So algorithms is a term that is going to that is like to create step-by-step procedure. Okay, so if you want to solve a problem, probably you need to understand what the problem is, and you need to find different ways to solve the problem, right? So to solve the problem, we need to define few steps. Okay, so that defining few steps are termed or called as algorithm. Okay, some set of rules and regulations that to be followed. That rules and regulations can be framed by ourselves. Okay, it is not a mandatory rules that is fixed by others. You can also follow others' rules that is fixed already, or you can frame your own rules and regulations to solve the problem. Okay, so why do we learn this particular topic in Robomind? The concept is Robomind, but why do we learn this? If a robo must be instructed, okay, once we switch on to the next topic, the next lesson, you can very clearly understand why all these topics are covered in the chapter. Okay, so once a robo is being given some instruction, the robo must follow the instruction, right? So to instruct the robo, we must understand how to instruct, right? So if I am coming to your home, okay, please take this scenario. If I am coming to your home, everybody will try to tell me the first thing you will tell me is your address, right? Ma'am, my address is so and so. You can come to my house with this address. Okay. So one will say in this way. The other child may tell like, ma'am, this is the location. So from here the landmark. Okay. So the other one will try to tell the landmark of your house, right? So you will tell the landmark, and from that way you can direct me like go left, go right, go straight, and take the third street, and fourth house is mine. So in such way you can just direct me by telling the exact route. So one can tell the address, literally the address can be said. The other can say about the location or the landmark, and the other can direct in a very particular way, like going on to this particular, take this road, second cross, third street, and the fifth house. So in such way, people may frame their own rules and regulations, right? They can frame their own set of rules. So this is how you are also going to instruct the robot. Okay. So to make the robot to follow some set of rules, you yourself going to create the rules. Okay, so that is why we learn all these basic things in this lesson. Okay, so I hope this will be very clear to you all, right? Okay, so that is what the topic which is stated now. So, and then we'll just move on to the next topic called flow chart. Okay, so you cannot simply tell. So as I said now, the third example, one will direct me in the way that how he or she is traveling regularly, right? Ma'am, I will just get on this bus stop. I will take the first cross and I will move on to the third street, and there fourth house is mine. So you frame some set of rules, right? So you direct me in a very prompt way. So here a flow chart is also the same. Okay, so a flow chart is simply going to tell what it is, just going to direct you what you have to do. Okay, so that is what the flow chart here it is. Okay, so sir, will you take over or shall I continue? Sir?
Okay, I'll take over, ma'am. Yes, sure.
Okay, sir.
Okay. All right. So let's continue on to flow charts. So flow charts are similar to algorithms. So in an algorithm, you simply write down all the detailed steps to solve a problem. But the problem may not be what do you say? You can't represent the solution properly if you simply write it down. So a flow chart is just a graphical approach. You write down the steps by using all of these graphical symbols. Yes.
Sure.
Yes. Yes. What is it about? Yes. Yes. Someone just interrupted. Do you want to say something? Okay. So let me just continue. So what I'm trying to say is the algorithm, though it's detailed, it details all the steps. It may leave off some important details. So this flowchart will basically fill in all of those details graphically. So anytime you're setting a set process, like here we have the algorithm to make hot water. Let me just use this example of making hot water. Anytime you're doing a specific action, this flowchart actually instructs you to use a rectangular block, like taking a pan or setting the pan on the stove. These are set instructions or actions. So we represent the set instructions or actions by using a rectangular block. But how about something like turning the stove off? When do we when should we turn the stove off? When making hot water. So we should only let me just answer. We should only turn off the stove only after the water gets hot. So here in the last step, we are making a decision. If the water is not hot, even after 5 minutes, we have to continue heating. So such intricate details are missed by the algorithm. So we can actually incorporate those by using a flow chart. This is an advanced technique to solve problems. So let me just demonstrate. Okay, let's not go into this too deeply. Let me just demonstrate, and maybe ma'am can add a few points. So here, let me just convert this algorithm into a flow chart. So I'm just starting off the sequence by using the keyword start. Then I'm using this rectangular blocks to write down set instructions, like taking a pan, setting the pan on the stove, placing the pan on the stove. These are all set instructions. There is no decision to be made here. Okay. Next, I have to add something to the stove. So I'm going to add heat to the stove. So this time I'm going to use this this block right here. Okay. So this is what we call as a parallelogram. I think it's called as a parallelogram. We use this block anytime we want to add external inputs. Okay, so these are the steps. I've written the steps to make hot water now. So just detail the steps like taking a pan, filling with water, placing the pan on the stove and turning on the flame. So once we've done all of these steps, the last step is the crucial one. So we need to take a decision. So once we turn on the flame, we have to decide when the water is hot. Okay, let me just write down simply. So once the water gets hot, we are going to turn this off. So to represent that decision of turning the flame off or on, we are going to use this diamond shaped block right here, right? So we can take two steps here. So we can test this after 5 minutes. So after a 5 minute interval, we can take a look at this block here. So after 5 minutes, if we see the water is hot, we can turn off the water. If we say yes, the water is hot, we can say turn off the water. Okay, let me just write the condition here. You can say check if hot. If yes, we say you've made hot water. We'll write success. Okay. If we say no, what do? If we check after 5 minutes, if the water is not hot, we can simply go back to this initial step here. We can simply go back to the stove, or we can resume the process. We can restart, or we can keep doing this specific steps again and again till we reach this step yes. Okay, this is a simple this is an oversimplification of the flow chart. This is just a concept. This is just a concept that computer science programmers and engineers use to solve very complex problems. All right. So this is just for you to understand. Don't worry about it too much. So here I have some sample flow charts. So here we have a flow chart to basically what is this? To make coffee right here. So if I think most of you don't know how to make coffee. So if you want to make coffee, you can simply follow all of these instructions. The way the flowchart is made is so that anyone that has no idea how to solve a problem can basically look at the flowchart and they can solve that problem. Here you can see all the steps are broken down neatly using all of these graphical symbols. And on your book also, you'll see most examples that are shown using the flowchart method. You can see when to start your program and when to stop, and what are the various decisions you make. You can see all of these. So don't get too confused or too attached. This is just to explain how programmers think. Okay. So let's continue on to the next topic called evaluation. So evaluation is simply to test your problem, to test your solution. So anytime, so even if you take something like cooking, so once you finish making your hot water, or once you finish making something like any food dish, so the final step is going to be tasting. So evaluation is just like tasting. You just check if the work you've done is up to standard, right? So evaluation is kind of necessary. So whenever you're trying to solve a problem, you want to make sure you actually your solution actually is sufficient. That is what you mean by evaluation. Let's not worry about it too much. Like I have a small picture here that explains the same. So when you have a problem, you try to solve it, and if the solution does not fit, you can actually go for a different solution, or you can change your approach. So change your approach that solves your problem. You can just see a small picture right here. So let me not dwell into this too much. Let's go on to the next topic. The next topic is called as dry runs. So dry run is simply another way of trial and error. Another way of calling trial and error. I think everyone knows trial and error. So when you have no idea what to do, or when you have too many number of solutions for a set problem, you can always go for this trial and error method. Trial and error method is simply you try out a simple algorithm, and if you check if it works out for you. Like here we have a small example here, a small picture. So here you have some people trying to get a load, uh, trying to move a load here. Here you can see they're trying to use square wheels. All right, let's say these people have no idea how wheels work. So the first thing they're going to do is they're going to use these square wheels. All right, and if they continuously do this, they're going to figure out that it makes more sense to use some other type of wheel. So they slowly change their approach, and finally they get to a wagon with wheels. So here you can see by changing your approach slightly, you make a better program. And if you change the approach, if you keep refining a program, you'll end up with a entirely different solution. Okay, so this is just an example of trial and error. These are all just techniques that programmers use. So since you're going to learn how to program, you just need to get initiated. You just need to get introduced with this concept. That's why everything is mentioned here. Okay, maybe ma'am may add something more.
Sir,
Yes.
that voice is coming, sir.
What?
Voice is wrecking, sir.
Why someone's voice?
Is it my one?
Yes, sir.
Children, everybody can mute your audio. Shri Varshan, please mute your audio. Fine, you will not have any disturbance now. Shri Varshan, please mute your audio.
Ma'am, do you want to add something?
No, sir, I think we can complete. We can
Okay.
just conclude the lesson.
All right. So children don't need to worry about any of these. These are just introductions. So once you actually start heavy programming, you'll need to actually look back at these concepts. So this is just an introduction of the way programmers think and solve problems. All right. So let's just head over to the activities. Maybe you'll have more fun doing the activities. Everyone, you can turn to page number 22. Let's try to solve some of these activities. Let me give you a second there. Turn to page number 22.
Everybody can have your pencil with you. Please don't use pen.
Yes, sir. Taken, sir.
Okay. So there are some questions here that ask intricate details about some concepts. So let's explain about all the different questions. Then you can write down the answer.
Okay, sir.
All right. First question. First Roman letter. Fill in the blanks. Learning new ways of thinking and solving a problem is what?
Computational thinking.
Very good. Well done. The answer is computational thinking. So learning to think like a computer, or learning different ways to solving a problem is what we call as computational thinking. Let me write it down neatly. It's a problem. Okay, computational thinking. Next, the computer acts on what cycle?
IPO cycle.
IPO cycle. Okay, let's just see. Let's just revise where we've actually seen this.
IPO cycle, sir.
IPO cycle. Does anyone remember on which page number we actually saw this concept?
22, sir.
Page number 5, not 52. Page number 5. Yes. If you take a look at
5,
page number
sir.
5,
5.
you can
Page
see.
number 5, sir.
Yes.
IPO cycle.
All right. So you can see page number 5. We've discussed about some examples also, like making orange juice. So to make orange juice, we need the input oranges. Then we need to mulch them up. Then we get the orange juice as output. Similarly, the computer uses various input tools and it does various operations and gives us outputs. Okay. So well done, everyone. So the answer here is IPO or IPOS cycle. Let me write down the answer. It's a IPO. All right, next question. What are similarities or characteristics that some of the problems share? What are similarities or
Pattern.
characteristics that some of the problems share?
Pattern, sir.
Okay, well done. Patterns.
Sir. Pattern, sir.
Patterns, very good.
Pattern.
Well done, everyone.
Page number 10,
Pattern,
sir.
sir.
Page number 10. Okay,
Pattern,
let me.
Pattern, sir.
Very good.
Pattern, sir.
Here we go. Very
Pattern,
good,
sir.
everyone. Very good. Well done. So here you can see the answer on page number 10. So you can mark down page number 10 or you can simply write down the word pattern on the question. So similarities of characteristics, some problems share are called as patterns. So let's write down patterns. Everyone, you have enough space to write down the answers. So let me also write neatly. So write down the answers in the space provided. Next, the process of breaking down a problem into smaller manageable parts is known as what?
Decomposition.
Decomposition.
Composition, sir.
Very good. Well done. Decomposition.
Decomposition.
See the answer. Very good, everyone. The process of breaking down a
Decomposition,
problem
sir.
is called as decomposition. Very good. Well done.
Page number 7. Okay, sir.
Page number 6, sir.
Okay, here we go. Page number 7.
6. 7, sir.
You can see the answer right here. The process of breaking down a problem into smaller manageable parts is known as decomposition. You see the answer right here. So let's write down the same. Okay, let me write it down. Decomposition. Okay, let's write down the next one. What will help to develop and progress the skills of computational thinking? What will
Computer,
help
sir.
to develop and progress the skills of computational thinking? Okay, what is going to help with computational thinking? That is the question.
Robomind, sir. Robomind.
Okay,
In
Robomind.
page number
Any
5,
other
sir.
answer?
Robomind, sir. 5.
Robomind, sir.
Where is the answer?
Number 5, sir. Answer is
Okay,
5, sir. Page number.
okay, let me check.
Robomind, sir.
Robomind, sir.
Sir.
Sir, it is given in the first line.
Oh, where is
Thinking
it?
is an art. Yes, there. Robomind
Okay,
will
okay.
help.
All right. So here you go. So here's the answer. Just write down Robomind. All right. So answer for the fifth one is Robomind. Next, sixth question. What is the general idea of the problem we are trying to solve?
Computer, sir.
No, no. What is the general idea of a problem we are trying to solve?
Abstraction.
Okay. Someone find the page number. Let's see.
Page number 4.
Okay, let me read out the question once again. What is the general idea of the problem we are trying to solve? Okay. Did anyone check page number 15?
So it is in page number 15, sir, the first line.
In create model.
Yes. So here you can see I'm highlighting the same. A model is just a general idea of the problem we are trying to solve.
Okay, sir.
Let me write down model right here. Next question. What are written as flowcharts? Dash are written as flowcharts.
Sir, my problem I rejoined, sir.
Okay, it's not a problem. We're just discussing the answers.
Problem, sir.
What are we writing?
Algorithm.
Instruction, sir.
Okay, let's see. A flowchart is just a diagram that represents a set of instructions. So let's see if that matches the answer. Okay, did anyone find the answer? Is it instructions or do you have some other answer? We're just discussing. Question number 7.
Sir, algorithm.
Okay, let's see if that fits.
Algorithm, sir.
Algorithm, sir. Yes, sir. Algorithm.
Algorithm.
Algorithm. Algorithm, sir.
Okay.
Sir,
Yes.
sir, algorithm.
Okay, let me just check if that is the answer. Yes, I think here you have it.
Sir,
The answer is right here.
algorithm.
Okay, just tell me the page number so I can just get it faster. So I think the page number is 16. On page number 16
Yes,
in the
sir. 16.
algorithm section, you have the answer right here. I can see they've given the answer. The algorithms are often used as starting point to create a program. They are often written as flowcharts. So this is what we just discussed right now. So you convert algorithms to flowchart and you use the flowchart to write code. So the answer is algorithms. Okay, though instructions may seem like the correct answers, here it's actually algorithms. So let me just zoom in so I can write properly. Okay. Next, what is the best ways to test the solution? Let's say come up with a solution.
Evaluation.
Yes.
Evaluation, sir.
Dry run.
I can see dry run. Evaluation means testing. So dry run is the way of testing. So here the answer is dry run. Okay. Well done, everyone. All right. So what and what, using what and what can we break down problems into smaller parts? Using what and what can we break down problems into smaller parts?
Sir, it is in page number 16, sir.
Okay, ma'am.
Computational thinking and decomposition. Making a plan. Yes. Second line, sir.
Okay, here we go. Here we have the answer. As ma'am just told you, here we have the exact line.
And the demonstration.
Here we see the exact line. Using computational thinking and decomposition, we can break down problems into smaller parts. So we've learned both of these concepts. Okay, not this one. We've learned both of these concepts. So let's write down the same answer. So the answer for this question is computational thinking and decomposition. So the space is not sufficient, but try to write within the space. So computational thinking and decomposition helps you break down the problem to smaller parts. Yes.
Completed, sir.
All right. Next we have
Sir,
another
you
set.
show the fill in the blanks, sir. I want to write last
Okay.
question, sir.
Okay, I have the answer right here. Let me show you. In the meantime, the others try to find the problem, find the answers for the other questions. Okay, let me give you a minute here. Ma'am, do you want to add anything?
No, sir, no, sir. We'll just proceed to the second Roman number, sir.
Okay.
Question and answer. Children, please write neatly. Don't scribble. Use your pencil to write. Okay, if you want to rub also, you can do it if you want to erase. So please use your pencil. Don't use pen. Okay, we'll just move on to the second Roman number, question and answers. Okay, so what is computational thinking? So the answer it is in fifth page. So the answer it is in fifth page, first line.
Okay. Let me scroll.
Yes, sir.
Computer can be used to help us to solve.
No, thinking is an art. In that paragraph, the first line. Learning new ways of thinking and solving a problem is called computational thinking. Children, either you can write it in the content book if you have sufficient place. Otherwise, you can take a notebook. Okay, single ruled notebook can be used to write the question and answers. In all the chapters, we have number of questions given. So please see to that you are writing in a notebook. Okay, that will look good as well. Take a small size single ruled notebook and you can write the lesson name. Okay, name of the lesson, today's date, and you can start writing question and answers alone. You need not write fill in the blanks in the notebook. Answer the following alone you can write.
Okay, ma'am.
Okay, that will look neat as well.
Okay, ma'am.
Sir, did you find the answer for second question, sir?
Ma'am, I found, ma'am.
Yeah, it is in page number.
Page number 10, ma'am.
Okay, good. Yes, it is in page number 10. Reusing code. So you can just make a simple change over there. Children, are you all listening? So another benefit of decomposition is that it allows programmers to easily copy and reuse the repetitive necessary blocks of code for other programs. So here the place of this another. Okay. So you can simply add reusing code allows programmers to easily copy and reuse repetitive necessary blocks of code for other programs. You can just strike out the first four words. Another benefit of decomposition is that you can just strike it out.
Ma'am, you said the answer for second question one more time, ma'am.
Yes, it is in page number 10. Please look at sir is presenting. So that block, the two lines you have to write. But instead, you can strike out the first four words. Another benefit of decomposition is that. Till that you can strike out and you can simply add reusing code allows programmers to easily copy and reuse repetitive necessary blocks of code for other programs. Okay, first five words you can please strike it out and you can just add reusing code.
Completed, ma'am.
Okay, so the third question is, what is abstraction?
I found, ma'am.
Yeah, it is in number,
Page number 14, ma'am.
page number 14, very good. Page number 14. So you can just leave the first line. Abstraction involves filtering out essentials, ignoring the characteristics that we don't need in order to concentrate on those that we do. Okay. So you can simply leave the first line. Abstraction is one of the key concepts of computer science that you can leave. And you can just start writing from the second point.
Sir, presentation ఎప్పుడు sir?
1 minute, 1 minute. I'm just bringing up the answer key. Just 1 minute, so you can just write better. 1 second.
Yes, sir.
So I think. Okay, here we go. Okay, shall I go on to the next question?
Yes, sir.
Ma'am, do you want to explain the next question or
No, sir. Yes, third question, sir. What is
yes?
abstraction? So whatever it is given in the key, they can just copy, sir.
Okay, ma'am.
Or shall we post this in classroom, sir?
Okay, ma'am. So we can post this in close classroom.
Okay, sir.
Ma'am, we can take screenshot, ma'am.
We'll give you the entire answer key. Okay. So children,
Answer key
don't
will
worry
be
about this
posted.
chapter.
Okay, sir.
Don't worry about this chapter. This is just an introduction. Some concepts may be somewhat advanced, but don't worry. This is just an introduction. Okay. So we'll post the answers for the first four questions. We'll post the answer for the first four questions in the Google Classroom. For whatever questions we've discussed the answer for, the answer will be available in Google Classroom. Just copy the same into your notebooks. So in the next class, we'll see some more
Yes,
answers
sir.
here.
Sir,
So
you
for the
will send this in Google Classroom, sir.
yes, some questions have not been explained that thoroughly. So once we get to that question, we'll actually see the definition and we'll see the answer. Like for this question 5, we've not actually discussed these terms. So in the next class, we'll discuss the terms, then you can write the answer. All right. So I'll be posting this first page of the answer key in Google Classroom, so everyone can answer. So the time is all 4:50 already.
Bye, sir. Thank
Wait,
you,
wait,
sir.
wait. Just go to Google Classroom and post your attendance for today's class.
Sir, I have
Sir,
posted my already
Post
attendance.
your
I
mark.
don't
Post
have
your
that
mark.
in
Not,
the
not post.
Already present, sir.
Sir, that is process, sir.
Already presented, sir.
Posted, sir.
Okay. Those who have not posted, please go ahead to Google Classroom and post your attendance. The
Bye,
others,
sir.
you
Thank you,
can.
sir.
Thank you, sir.
Okay, then everyone you
That
can
is
disconnect.
started, sir.
Fine.
second, sir.
Bye, sir.
Children, post your attendance in classroom and then you can start leaving the session.
Thank you, ma'am, sir. Thank you, sir. Thank you, sir. Bye, sir. Thank you, sir. Bye. Thank you, sir. Bye.
Thank you, sir. Bye, sir.
Thank you, sir. Bye, sir.
All right, everyone.
Thank you, sir.
Bye.
Bye.
Yes. Yes. Thank you for attending.
Thank you, sir. Bye, sir.
All right, everyone. Goodbye. Yes.
Thank you, sir. Bye, sir. Thank you, ma'am. Thank you, sir. Bye, sir.
All right, everyone. Bye.